Hi, my name is Kyung and I'm a software engineer in CS373 company. I found that our company uses a bubble sort for sorting algorithm, and I think it is pretty inefficient. So I want to introduce a new algorithm called merge sort and compare with bubble sort in terms of time and memory efficiency, and see why merge sort is more efficient than bubble sort. But before that, I will briefly explain about each algorithm. I will assume that the data should be sorted in ascending order. So how does bubble sort works? Well, from the start of the array, it compares two elements at a time and swap when the element on the left is bigger than the right. Then there will be a largest number at the end of the array. This is sorted, so you start comparing it again from the start, excluding the sorted element at the back. If you repeat this until every element is sorted, it will eventually look like this. Then what is time efficiency of a bubble sort? For the size of the input n, bubble sort goes through every element n times in outer loop. To be exact, it is n-1 times from the first element to second to the last element. In inner loop, which is operated per each element, it requires n times of swapping. In practical, however, it is less than that. The longest loop of swapping will be n-1, which is at the first time of getting into an inner loop. So the time efficiency would be multiple of n-1 and n-1, which is n squared in big O notation. When I run the bubble sort with previous example, the number of steps are n squared. The memory efficiency is big O of n out of n inputs because it does not require additional memory spaces. Now I'm going to explain merge sort and how effective it is. The merge sort first helps the array until it cannot be divided, and sort as merging the array. Since it is a recursive function, the front part is divided and merged, then the back part. Let's take a look at the code and see the time efficiency. In this merge sort method, it called a helper function called divide. I divided once prior to call divide in merge sort. And the divide function requires log n times of halving, and in this code it would be log n minus 1 because I did division in merge sort. Anyway, it is log n altogether. For each of division, it involves merging, which takes n times when walking through each element. Actually, it is smaller than n in reality, cause size of the array gets smaller as it gets divided. For the size of the input n, the time efficiency is n log n in big O notation. You can also see that in program execution. For each division, which is log n, there are n times of operations. What about memory efficiency? Out of n inputs, the call stack will need to store n elements for help merge function. This will be many as log n because help merge is called by division. Plus, there is initial memory size, which is n out of n input. So the memory efficiency is n log n. It looks like both algorithms takes around the same time when the number of elements are small. But when the size of the input is increased, the difference of efficiency is shown more dramatically. Can you see the gap between two graphs? Red line, which represents efficiency of a bubble sort, takes a whole bunch of time as the number of elements increases. This graph shows memory efficiency. Although the number of elements have increased, there are not much difference between the two lines. Therefore, I think our company should use merge sort instead of bubble sort. Although bubble sort algorithm has higher memory efficiency, merge sort is way faster than the bubble sort if there are many things to sort out.